Very good afternoon. At any point of time, suppose if connection is lost or something happens, and feel free, just you can interrupt me, and so that I can uh, check it.
Okay, sir.
Right. So when it comes to the database management systems, in database management system, we have certain topics, and I have divided the syllabus into three parts. One is called database design, database implementation, and database maintenance. And in a database design, we have a topics called entity relationship data model, relational model, schema refinement. That is called functional dependencies and normalization. And in the implementation part, we have a topics relational algebra and calculus and structured query language. And in the maintenance part, we have a transaction management and concurrency control, recovery management, and file organization and indexing. So we have these topics. From these topics, you are getting some questions. When it comes to the weightage analysis, like means how many marks you are going to get from DBMS. From DBMS, when you look the past 7 to 8 years of papers, I did this kind of analysis to show you what topics questions are asking, how many questions are asking. In 2024, there are two sets of gate paper. In ER and relational models, we got one mark question, and functional dependency and normalization 3 marks, one mark question and one 2 marks question. And relational algebra 1 mark question, in transactions and concurrency 1 2 marks question, indexing 1 mark questions. Totally 6 questions comprises 8 marks. In set 2 also 6 questions comprising 9 marks. In 2023, there is actually when you see the past 10 years of paper, the least number of questions asked in 2023. Only 3 questions are asked, and that too 5 marks only. And when you see 2022 7 marks, 2021 6 and 9 marks, 2028 marks, like 8, 6, 8, like you can see an average you can expect 8 marks from the subject. Okay, if you are studying DBMS, an average 8 marks you have to get it.
Okay, sir.
And that 8 marks from which topics? Like when you look for ER and relational models, most of the times there are 1 mark questions are asked, and sometimes 2 marks questions also given. And more importantly, you are getting 2 marks questions from the functional dependencies and normalization. And algebra and calculus is also very important. And definitely you can expect a question on SQL and transactions and concurrency. Repeatedly questions are asked, right? And recovery management, I think maybe you are told or not, I don't know. In recovery management system, so far there are 3 questions are asked. Recently, it means in 2021, 1 mark question asked. And finally, indexing, the questions are asking of 1 mark and 2 marks questions are asking. So by looking this, on average, you are going to get 8 marks from the subject. Okay, 8 means not less, 8 means good. And you observe that 8 marks are from different topics. Look at, no topic has repeated number of questions, right? So that on average, you can expect 8 marks from the subject. Okay, this comes to the weightage analysis. If required, you can take a snapshot of it, or else I will share you in your group or something else. If anything is available, I will share this PPT with you. And
Okay.
coming to the first topic, okay, because we have these 8 topics, we'll start with the first topic, entity relationship data model. From ER model, what questions are asked? So the questions are of type on notations, ER notations. The questions on ER notations, like what is a notation for multi-valued attributes? What is a notation for derived attributes? In 2024, I think, one question asked, like What is a notation for weak relationship set? What is a notation for weak relationship set?
Double rectangle, sir.
Weak relationship set, I said.
Relationship.
Weak relationship, double diamond.
Okay, sir.
It is called weak relationship. In 2023, I think in 2023 or 2024, it is given what is a notation for weak relationship set. Okay, now what is this notation? Double
Entities,
ellipse.
sir.
Double ellipse.
Weak entity.
Oi. Double ellipse is called multi-valued attribute. Do you know?
Okay, sir.
What does it mean, multi-valued attribute? An attribute that takes more than one value.
Sir,
Right?
actually, I prepared 8 subjects for this 2024 GATE exam, sir, and I ignored this DBMS, so I don't know anything about this subject.
Acha. Have you gone through the lectures? This sir?
No, sir.
No. You said
No, sir.
you have listened to Naveen sir's lectures.
Yes, sir. Some basics of this subject, sir.
Okay. Don't worry. Just I'm going to revise it because in the
Okay,
meeting
sir.
some other people also there, na? So others also respond it. Okay, don't worry. Hmm?
Okay, sir.
If you know it, happy. Otherwise, just keep on listening to me. Hmm? Fine.
Okay, sir.
And this dotted ellipse is called derived attribute. Derived attribute. Like this, we do have questions on notations. So one possibility is that asking questions on ER notations. And the second possibility, the questions on cardinality ratios. What are the cardinality ratios? We have 1 to 1, 1 to many, many to 1, and many to many cardinality ratios. We have 4 cardinality ratios. And when you look for these 4 cardinality ratios, 1 to 1, 1 to many, many to 1, and many to many. When you look for the cardinality ratios, this cardinality ratio is between two entity sets A and B, A relationship with B. If it is one-to-one cardinality, we have a key constraint from both the sides. I hope what is the meaning of key constraint? It means A uniquely determines B. So A uniquely determines B. We call it as a key constraint. Means 1A will determine how many B's? 1A will determine 1B maximum. 1B determine maximum how many A's? 1A. That's why we can call it as a one-to-one cardinality. Means 1A is associating with 1B. 1B associating with 1A. So when unique determination is there, we have a arrow. And when it comes to the one-to-many, A relationship with B. A relationship with B, the cardinality is 1 to many. It means each A associating with how many B's? Each A associating with how many B's? Many B's. And each B associating with how many A's? 1A. This is how we have to read it. Because 1B associating with 1A, we can say A is not a key to the relationship, but B is called a key to the relationship. Similarly, when it comes to the many to one, A relation B, and what is the cardinality here? Many to one. Means 1B associating with how many A's? Many A's. But 1A associating with how many B's? 1B. Means A uniquely determining. We call it as a key constraint. I hope you know it. Okay. And A relationship B. The cardinality is many. It means 1A associating with many B's. When 1A associated with 1B, we have a key constraint. When 1B associated with many A's, it is not a key constraint because one associated with another one, we have a key constraint. Now, what are the points here? In 1 to 1, we have a arrow from both the sides, right? We have an arrow from both side arrow. And this translation is required, very important to understand the conversion of ER models to relational models. In one many and many one, the arrow is from which side? Look at one many. The arrow is from B side. B side means B side is M. In many one, arrow is from A side. A side is M side. We can call in one many and M1, arrow is from M side. We have M side arrow. Arrow is from M side. When it comes to the many, do you have any arrow? There is no arrow possible. Means no unique identification is possible. Actually, this translation is much helpful in solving most of the previous gate questions. Most of the previous gate questions are based on this concept. And if you know this translation, this is very important for you. Okay. Now, one possibility is on ER notations and another possibility on cardinality ratios. Okay. And we also have total participation, weak entity sets, weak relationships, and hierarchical relationships. But scope is there for notations, means exclusively when I'm talking about ER diagrams. Questions from ER diagrams. Questions are possible from ER models, ER notations, and cardinality ratios, especially. This is expected. Now we'll see one of such questions. Here, in 2023 GATE, there is a question asked, like this is what I'm talking about. Okay, this is question on relational model. Okay, which of the options given below refers to the degree? And what is the meaning of degree? Now, degree specifies the number of tuples stored in the relation. The degree specifies, means one table. This is on relational models. Okay, I'll skip this question for a moment. And I'll give you this question later. I'll give you that question later. Now, have a look this question when I'm talking about the questions on ER models, exclusively on ER. You may expect a question like this. Look at, suppose is part of is a relationship type with two participating entity types, district and state. Now, question is, what is the appropriate cardinality ratio for district to state? This kind of questions are possible. Can you expect what is the appropriate cardinality between district to state? And if you know it, feel free, you can tell your answers either orally or else put your answers in the chat box. Just let me check how many were there in the meeting. Just let me check how many were there in the meeting. Okay. Balaji.
Sir, no, sir, I don't know. Please explain, sir.
Actually, you don't know this concept? Fine.
No, sir.
Don't worry. Yeah, look at here, district to state. The cardinality it is asking. Okay. So means you take district at left side. I'm just checking district at the left side and state at the right side. State at the right side. And between them, we have a relationship called is part of. Is part of means district. We can say the relationship is like this. District is part of a state. Now, possibilities, like what general possibility? One district belongs to how many states? Like each district belongs to how many states? Every district belongs to how many states? What you can expect? One state. Okay. And one state can have how many districts? Look at it this way. One state can have how many districts?
Any districts?
Many districts. So what cardinality is possible? Many to one.
Many to
Simple.
one.
So you can read in this way. Each district is part of one state. And each state can have many districts. So the probable cardinality is many to one. Means the cardinality is many to one. Okay, in the similar way, can you try this question? Just read this question. Okay, don't worry. Even if you don't get it, don't worry. I'm there for you to explain you all the possible questions. Okay, just before that, I'm asking you just check for it.
Okay.
Just take 1 minute or 2 minutes of time, not more than that, and try to understand. After that, I'll explain.
Sir, 1 and 7, sir.
1 and 7. Super,
7.
super, super. Okay, just let me explain so that you will get a clarity. Very good. Good try.
Okay, sir.
What is given? Suppose assigned is a many to one relationship. Okay. Assigned is a many to one relationship. And the relationship you have to show with a diamond box. And this is a many to one relationship between two participating entity types, employee and department. Means one side we have employee and another side we have a department. Okay, this side I'm writing employee because it is set employee to department. So employee in the left side, department in the right side. And just now in the previous exam, in the previous slide, I have explained, means very first slide when I was explaining cardinality. Many to one. Many to one means we have an arrow from which side? We have an
Any
arrow
side, sir,
from
from department. Sorry, from employee.
M side, right? From employee. Okay, forget about that arrow also. But what it said, a maximum of 7 employees are assigned to a department. It is meaning that one department can have maximum 7 employees, correct? See,
Sir.
each department can have maximum of how many employees? 7. Means we can say it is a 7 to 1 cardinality. Okay, 7 employees, and both are participating totally in the relationship assigned. So the total participation, it is meaning that every employee should be assigned to some department. Actually, total participation in ER model represented with a double line. Okay, and department is also totally participating. It is a meaning that every department is assigned maximum of 7 employees. Okay, maximum 7, it means that minimum how many employees? 1 employee. Okay, because it is a total participation. Total participation means every department definitely participating in the relationship. So now how the cardinality is showing in the form of min max, like in the ER diagram, the line connects employee to the relationship. Employee to relationship is assigned to be labeled x comma y using min max notation. So between them x and y, okay, using min max notation. X is minimum and y is maximum, means each employee associated with minimum how many departments and maximum how many departments. Now look at how to read this. Read this. Each employee associated with how many departments? 1. Correct?
Sir.
Each employee associated with how many departments? 1.
1 department.
And whatever we mentioned on the cardinality will be the maximum. Okay, so means
Yes,
maximum
sir.
is 1, and minimum, each employee associated with maximum 1, but minimum
1 employee.
also 1. Sorry, minimum is also 1. Each employee associated with minimum 1 department
Yes, sir.
and maximum 1 department. Okay, so the line connecting employee to assigned is 1 to 1. Okay, it is a meaning that one employee assigned to maximum 1 department and minimum is also 1 department. Why minimum 1 department? Because employees participating totally. Totally means for every employee there is a relationship. And if it is not total participation, then minimum should be 0. Keep in mind, if it is a total participation, minimum will be 1. Okay, I'm writing. If it is a total participation, minimum will be 1. Okay, maximum will be the number. Okay, yeah. Okay, maximum will be the number at the other side. Okay, maximum will be the number at the other side. Employee, it is associated with cardinality 1. Maximum is 1. So means, what is the question asked? Employee. Now, if in the ER diagram, the line that connects employee to the relationship type assigned is to be labeled with x comma y using min-max notation. Choose the correct option. So employee 2 assigned, minimum 1, maximum 1, then answer should be option B. Okay. Now suppose if I'm asking you, between department to assigned, again same logic. What is a min-max relationship? Department to assigned. Can you try?
Sorry, sir, I didn't understand the question.
So previously what I asked, employee to assigned minimum how many participations, maximum how many participations. Okay. So each employee associated with minimum one department because total participation,
Yes, sir.
and maximum one department because cardinality number is always says maximum. Okay. Now this is x comma y min max is between employee to assigned. Now I'm asking a question between department to assigned. This one I'm asking you. What is the minimum participation, maximum participation of department with assigned?
0 and 1, sir.
I think you're not getting the cardinality. So you look at. So how do you read this cardinality? Each department, see, each department assigned. Look at each department assigned to maximum how many employees?
7 employees.
7 employees means maximum is 7. Okay. By looking the cardinality, we can understand maximum. But minimum, how many? Just now I told you, if it is a total participation, minimum is always 1.
1.
So means between department to assigned is 1 to 7. Minimum 1, maximum 7. Between employee and assigned, minimum is 1, maximum is also 1. Got it?
Okay, sir.
So simple. Whatever is the number on cardinality, that is a maximum number. Okay. So, but participation, if it is set total, minimum is always 1. If participation is set partial, minimum will be 0. This one. This kind of logical questions are possible to be asked. Okay. Any doubt?
No, sir.
Right. Now, can you try one question? Just I'll give you to make you understand. Suppose a professor, just I'm giving you one question. Professor teaching some courses. Professor teaching some courses. Assuming one professor, look at one professor teach 3 courses maximum, and each course taught by one professor. Means I'm telling that cardinality is 1 to 3. 1:3 is a cardinality. How do you read this 1:3? We can read in this way. Each professor teaching maximum 3 courses. Okay, cardinality is always maximum 6. And each course taught by how many professors maximum? 1 professor. Each course taught by maximum 1 professor. Now, here this cardinality is between the two entity sets. Now, what I'm asking is, each professor associating with how many teaching relationships? Minimum and maximum. Similarly, each course is associating with how many teaching relationships? Minimum, maximum. Can you try? Each professor teaching how many courses? Minimum how many courses? Maximum how many courses? Each professor teaching how many courses maximum?
3 courses, sir.
Maximum is 3. Okay. This way you read it. And minimum how many courses?
Minimum 1 course.
Yeah, good. Minimum is 1. When minimum is 1? When there is a participation is total.
Total.
If it is a total participation, the line should be double line. But here, which line is
Okay, sir.
there? Single
Single
line.
line. So 0.
Single line means partial. It means minimum will be 0.
0.
Okay.
Okay, sir.
Now at least tell me from this side. Course to teachers. Minimum.
Teachers. Minimum 0, maximum 1, sir.
Minimum 0. Maximum 1.
Maximum
Perfect.
1.
Perfect. Why? Because like each course taught by how many professors? 1.
One
And whatever
professor.
the number we mentioned is maximum always. And
Yes, sir.
minimum 0 or 1. We have to check. It is single line or double line? Single line.
Single
Single
line.
line means partial. Partial means minimum 0. Total means minimum 1. Simple. 0 and 1. Understood? Na? This kind of question?
Yes, sir.
Okay, very good. So means on ER model, you can expect this kind of questions. Simple, like on simple notations on cardinalities. These are the two possibilities where you can expect a question. And when it comes to the relational models, you can expect questions on relational models. What is a relation? Like basic terminology. Questions on terminology, because previously asked questions on terminology. Now, what is a relation? Relation is nothing but a table, and every relation should have attributes. And the structure of a relation, we call it as a schema. And whatever the tuples that are there in the relation is called instance. Okay, so here student table, fine. Student table will have attributes roll number and name, right? And roll number is integer, name is a character of 10 characters, and roll number is a primary key, assuming. Now this is called structure of a table. The structure of a table is called relation schema, and we can have some records: 1 Rajesh, and 2 Ramu, and 3 Rani, some records. These are called instance of a relation. Okay, schema means structure, instance means records. And the number of attributes is called degree. Degree is nothing but number of attributes. This was the first question I was showing. Here in this example, how many attributes are there in the table? 2 attributes. Then we can call degree is 2. And the question in the previous gate, it is asked what is a question on number of attributes. And there is a question on cardinality. Cardinality specifies the number of tuples. How many tuples? In this instance, 3 tuples. Then we can call cardinality is 3. Previously, question asked on degree. Now you can expect a question on cardinality, basic terminology. And you can expect a questions on the integrity constraints. Integrity constraint means conditions on the database schema. Integrity constraints. What are the conditions on the database schema? We have a primary key condition, unique condition, not null condition, foreign key condition, and check condition. These are called integrity constraints. Now, these are the 5 integrity constraints that can be shown on the table of a database. And here, how do we show the relation between them? I can say primary key, unique, not null, foreign key, all with reference to whether it is allowing duplicates or not, and whether it is allowing null values or not. Based on the duplicates and null values, we have to decide what condition it is. Primary key duplicates, yes, allowed. Null values, primary key will allow duplicates, yes. Primary key will allow null values, yes. Is it yes or no? No, actually. Primary key will not allow duplicates. Primary key will not allow null values. So means no duplicates, no null values. We can call that particular column is a primary key column. And when it comes to the unique, means no duplicates, but null values are allowed. Not null. Not null, it means no null values, but duplicates are allowed. But foreign key allows duplicates as well as null values. And check is for writing user defined conditions. Means you can write your own conditions. We have to use foreign key constraint. Sorry, check constraint. Right. Suppose I wanted the marks of a student should be minimum 20. So we can write a check conditions. These are the 5 integrity constraints. Primary key will not allow duplicates, not allow null values. Unique will not allow duplicates, but null values are allowed. Not null will not allow duplicates. Not null will allow duplicates, but null values are not allowed. Foreign key will allow both duplicates and null values. Check for writing user defined conditions. And next, you can expect questions on key constraints. Key constraints. We have 3 types of key constraints: candidate key, super key, and third one is primary key. I hope you know this. Every relation, every table should have one primary key, and this one primary key we have to choose from the candidate keys, and every candidate key is a subset of super key. It is a relation between primary key, candidate key, super key. And when I'm talking about a key, what is it? Key should identify a record uniquely. Unique identification of a record is possible using key constraint. So what is super key? Which has unique identification of records in the table. When I can call a super key is a candidate key, the subset, if it is not a key, again we can call it is a candidate key. We can call candidate key is called a minimal super key. When I can call minimal super key, let me explain. Suppose A and B attributes together, assuming, is super key. A and B attributes together is called super key. And if A is not super key and B is not super key, then AB is called candidate key, and one of the candidate key can become primary key. This is important. Most of the students confuse here. Suppose I am assuming A and B attributes together is a super key. It means this combination always has unique values. No duplicates in this combination is called super key. And if this combination is a super key, it is mandatory that A alone should not be super key, B alone should not be super key. Then only that combination is called candidate key, and one of the candidate key should become primary key. And exclusively on relational models, you can expect questions on one more topic. That one more topic is called foreign key constraint. What is a foreign key constraint? Foreign key constraint is to show relation between the two tables. To show relation between the two tables, we use a foreign key constraints. And we know that duplicates are possible and null values are possible if some column is declared as foreign key. And something around 4 to 5 questions asked in the previous gate on foreign key constraints. I'm going to discuss some of them and some of my own set of questions for your practice. Okay. Sure. Now, here, as I told you, in the relational model, you can expect questions on terminology. Very first, I have explained first question. This is actually, this should appear in the relational model. Instead of ER model, this should appear at the relational models. Now, what is the question here? Which of the options given below refers to the degree or RET of a relation in the relational model? What is a degree? Degree specifies number of attributes. This is a question asked on terminology, number of attributes. Okay, sorry. Here, degree specifies number of attributes. What happened to my pen? Degree specifies number of attributes. Here look at option A, number of attributes of its relation schema is called degree of a relation. But number of tuples is called cardinality,
Cardinality.
right? So that B is wrong, A is right. Number of entries. Entries means tuples are records. It is also called cardinality. And number of distinct domains. Domain is nothing but type. Different types. Is it representing the is it representing the degree? No. Degree specifying the attributes, not with respect to domains. So C is wrong, D is wrong. Correct answer is A. This is what one I told you. Based on the terminology, questions are asking. And the second thing, the questions on integrity constraints and key constraints. In the integrity constraints, I have talked about primary key, unique, not null, foreign key check. Exclusively on integrity constraints, so far not asked, but scope is there for asking questions. On key constraints, we have a candidate key, super key, primary key. As we told, as I discussed, what is super key? Superset of candidate key is called super key, right? Superset of candidate key is called super key. And what is a candidate key? Suppose if A, B together is a super key. If A is not super key and means two conditions to be true. B is not super key, then AB is called candidate key, and one of the candidate key can be taken as a primary. Now look at this is a question in GATE 2016 asked on candidate key and super key and primary key. Look at what is the question. Which of the following is not a super key? In a relation schema with attributes V, W, X, Y, Z and the primary key Vy. If Vy is a primary key, I can call Vy is candidate key. Now question is not a super key. Which is a super key? Superset of candidate key is called super key. Now which is not the superset of this candidate key is not super key. Now tell me what is the answer for this question? Try.
B, sir.
Very good. B is the perfect answer. Why B? Because in the option A
Y
we
is not.
have Vy. In option C we have Vy. In the option D we have Vy. But in option B we have V but no Y. It is not super key. Why? Because super key means superset of candidate key. So V there but not Y. It is not superset. Remaining all are supersets. So B is the perfect answer. Very good. Now, can you try this question based on the foreign key constraint? As I told you, one is on terminology and another is on key constraints and another more importantly on foreign key constraints. Now, I hope you have studied. Okay. Could you please try this question on foreign key?
Sir, option B, sir.
Option B, very good, but that is wrong. Okay.
Items.
It is a question in GATE 2005. What is asked? A is a primary key. Listen, I'll explain you in a simple way. What is given? A is a primary key and C is a foreign key that refers to A with on delete cascade. What is the meaning of on delete cascade? Whenever a record is deleted from the primary key, the related record that refers to that related record in the foreign key also be deleted. So means the table that has primary key is called parent table. The table that has foreign key is called child table. But both primary key, foreign key here in this table we have one together. So means the same table is act as a parent table as well as a child table. When the same table act as a parent as well as child, what happens? Now what is the question given? The set of all tuples that must be additionally deleted to preserve the referential integrity, means foreign key constraint, when the tuple 2 comma 4 is deleted. When you delete 2 4, see 2 is under primary key column, a column. So means with respect to this 2, I can call it as a parent. Now I have to see what are the related records of this 2. Now we have to see this 2 is present. This 2 is present in which tuples? In the column C. The 2 is present in column C for the tuple phi 2, and the 2 is present. The 2 is present. The 2 is present in the foreign key of 7 2 tuples. It means for 2 4 we have a phi 2 and 7 2 are called child records. Now what we have to do with the child records? What on delete cascade says, whenever you perform the delete on the parent, the child records also be deleted. That is the meaning of on delete cascade. So means when 2 4 deleted, the related record, now 2 in the child. The 2 in the child is in the records 5 2 and 7 2. That child records also deleted. But whenever you delete this 5 2, what happens? That 5 is deleted from the parent. Whenever you delete 5 2, 5 is deleted from the parent. When 5 is deleted from the parent, again we have to check that 5. Look at here, I'm deleting 5. Because that 5 2 record is deleted now we have to check its related record. Its related record means 5 we have to check in the column C. That is a foreign key. Now 5 in the column C for which record? The 5 in the column C for 9 5 record. It means for this is a child record. Now what is to happen with child when parent is deleted? On delete cascade means this child record is also be deleted. So 9 5 also deleted. And parallelly you have to keep on check all the possibilities. Look here, when 7 2 deleted, when 7 2 deleted, 7 is deleted from the parent, but in the column C we don't have 7. It means for 7 2 we don't have a children's, right? So that no more tuples to be deleted. It is a meaning that whenever you delete 2 4, the for 2 4 we have a 2 child records 5 2 and 7 2, that is to be deleted. Whenever 5 2 deleted, its child also to be deleted 9 5. But for 9, do we have any child records? But 9 is not in the column C. So there are no childs for 9 5, no child for 7 2. It means deletion of 2 4 causing deletion of 5 2 and 7 2. Again deletion of 5 2 causes deletion of 9 5. So that what are the tuples that need to be deleted additionally? Not just 5 2 and 7 2. In addition to 5 2 and 7 2, it also requires to delete 9 5. So answer for this question is option C. Is it clear?
Yes, sir.
Okay, done. Very good. So if it is clear, I suggest you try one question. I suggest you try this question. Okay, have you understood this question at least?
No, sir.
Okay, okay. Haven't solved these kind of questions in the lectures?
No, sir. I didn't solve this question.
Okay, fine. So what is given? Consider relation GEQ, which represents greater than or equal, that is x comma y belongs to GEQ only when y is greater than or equal to x. Okay. Now, how this GEQ is represented? GEQ is represented as create a table GEQ. There is LB, that is integer, and UB, it is also integer, and it is mentioned primary key is LB. Okay, primary key is LB, and foreign key is UB references to GEQ. Means foreign keys always refers to primary key. Keep in mind this one. UB set as foreign key, and that foreign key is referring to which table? GEQ table, means same table. So always foreign key refers to primary key. With what condition? On delete cascade. Just now I told you on delete cascade. What happens when in the case of on delete cascade? On delete cascade, whenever it performs, it is going to delete child records when the parent records also be deleted. Now, here, what is the question? Which of the following is a possible if tuple x comma y is deleted? If x comma y is deleted, what is possible? Just now I have explained. Look, here assuming this is x, this is y. If xy is deleted, what is happened? X is under primary key column. Whenever x is deleted under a primary key column, we have looked x under foreign key column. This is x under foreign key column. This is x under foreign key column. Right now. So that records also to be deleted. So this way you have to check. So it is a meaning that if xy is deleted, right? Xy is deleted, x under foreign key column is to be deleted. Is x is under primary key column, when it means with respect to x, I can call it as a parent. If this is deleted, x under foreign key column is also to be deleted. But what options are given? A tuple z comma w with z greater than y is deleted. It means in the second column x is not there, but second column x is possible. But it means you have to think about in the alternative way. Look, see, if 2 in the primary key is deleted, 2 in the foreign key we have deleted, and deletion of this one causing something else on the primary key is deleted. So that something else, 5, we have checked again that 5 in the foreign key column. That tuple also deleted. So this is a chaining process. In the chaining process, if xy is deleted, so x in the foreign key column is to be deleted. Okay. And x in the foreign key column deleted means in the uh, primary key column something was there. Okay, there may be something in the primary key column. Something in the primary column, assuming in the primary column we have a w, because it is mentioning zw. So assuming primary column w is there. Whenever you delete this record, w in the primary key column is deleted. So whenever w in the primary key column is deleted, which record is to be deleted? W in the foreign key column is to be deleted. Correct? So here what is mentioned, when xy is deleted, it is causing zw. Okay, zw is also deleted. Now observe, when x is deleted from the primary key column, because on delete cascade condition is there, x in the foreign key column is to be deleted. Deletion of x in the foreign key column may causes w in the primary key column is deleted. When w in the primary column is deleted, w in the foreign key column also to be deleted. This is a chaining process, correct? Now this is a chaining process. Now if we have some record x comma y, that is GEQ, x comma y in the table, so what is the condition to be satisfied in the record? Y should be greater than or equal to x. So means what is the possible relations between the records? Y, x comma y belongs to GEQ, then y greater than or equal to x means the second value should be greater than or equals to first value. Look, y greater than or equal to x possible from this. Here, what is possible? Second foreign key value is greater than or equal to primary key. X greater than or equal to W possible. Here, Z comma W means what you can expect? What you can expect?
W greater than or equal to Z.
Very good. Now, when you combine all this, Y greater than or equal to X greater than or equal to W greater than or equal to Z. Correct now? This is the relationship we got it. So means whenever you delete XY, it causes WX is deleted. That itself causes delete ZW. Here, what is the question asked? When XY is deleted, you also required to delete ZW. At what condition that ZW is to be deleted? Z greater than Y? Look, is Z is greater than Y? No. Y is greater than Z. So means option A is wrong. A tuple Z comma W with Z greater than X. Look, between Z and X. Is Z greater than X? No, it is X greater than
No.
Z. So B is wrong. C. W less than X. Look, between X and W. What is the relation given? W is less than X. Very good, it is correct now. X is greater than W means W is less than X. So C is the correct answer. And deletion of XY is prohibited, wrong. Why? Because we have an on delete cascade. Whenever a record is deleted from the parent, the child record also be deleted. So D is wrong. Correct answer is option C. And if you want it more easy to understand, I'll give you one more example. Is it understood first, this analysis?
Yes, sir.
Okay. Just I'll give you in a more simpler way. Okay. Look at what is asked. This is a table definition is given. XY belongs to GEQ only if Y greater than or equal to X. Okay. Y greater than or equal to X. Assuming I'm taking 6, 6. This is X, this is Y now. 6 greater than or equal to 6, correct. And 5, 6, correct. 6 greater than 5. 4, 5, 5 greater than 4, correct. 3, 4, look, 4 greater than 3, correct. Assuming if 5, 6 is deleted, just I'm telling you in a simpler way. If 5, 6 is deleted, what should happen? Wherever 5 is deleting from the primary key, wherever 5 in the foreign key column, that is also to be deleted now. It means for 5, 6, 4, 5 is the child. Because 5 is deleted, 5 in the foreign key column tuples are to be deleted. Now deletion of 4, 5, what it causes again? Deletion of 4, 5 causes 4 in the primary key column is deleted. When 4 in the primary key column is deleted, now what is to be deleted? 4 in the foreign key column. Now, where is 4 in the foreign key column? For record 3, 4. This is to be deleted, right? And this is a chaining process. Now, what is mentioned? XY is deleted. Look, XY is deleted. Okay, this is X, this is Y. X is 5, Y is 6 is deleted. Now, what is also to be deleted? Z comma W. Here, this is 5 is X, X is 5, Y is 6. Okay. So here, this is something else. We can call W comma X. But here, what is mentioned in the question Z comma W means I'm calling this is Z comma W. Now look, between X and Y, what is the value of X? 5. What is the value of Y? 6. And what is the value of W? 4. What is the value of Z? 3. Correct now? So when 5, 6 is deleted, we got 4, 5 deleted. When 4, 5 got deleted, we got 3, 4 to be deleted. I'm chaining. Now, 5, 6 we call XY, 3, 4 is called ZW. So we got X, Y, W, Z values. So in option A, what is mentioned? Z greater than Y. What is the Z value? 3. Greater than Y, 6. Is 3 greater than 6 is correct? No, incorrect. Z greater than 6. What is Z? 3. What is X? 5. What is the relation given? Greater relation. But 3 greater than 5? Wrong. W less than X. What is the W? 4. What is the X? 5. What is the condition given? 4 less than 5. Correct, na? So option C is correct. No deletion. It is wrong. Why? Because whenever on delete cascade is there, deletion is possible. If on delete cascade not there, deletion is not possible. I think this will be easy explanation by taking some example. Is it clear?
Yes, sir.
Right. On foreign key, so far something around 5 to 6 questions asked on foreign key in the previous gate. So undoubtedly foreign key is very important, and this kind of questions will play important role in your gate rank. Next possibility is questions on ER models to relational models. So means it is a conversion. Now, how to do the conversions? Look, every entity set should be represented as one table. Every relationship should be represented as one table. But relationship should be shown as no separate table. No separate table means relationship is to be merged. You have to merge relationship with entity set. You have to merge relationship with entity set. In the case of if there is a key constraint, means arrow. That key constraint is called arrow. If we have arrow, we have to merge it. The point is very simple. Look at, I'll give you one simple example. This is A relationship B. Assuming the cardinality is many to many. Many to many, it is a meaning that there is no arrows. As just now have explained when I was explaining cardinality ratios. Many to many means no arrows. When there are no arrows, every entity set one table, every relationship one table. Means how many tables possible? A one table, B one table, R one table. So there are three tables possible. But whenever you look arrows, you can find differently. A relationship B. Assuming cardinality is many to one. Just now I have explained when it is in the case of many to one, arrow is from which side?
From A
From A.
to
Very
R.
good. A to R is a arrow. Whenever A to R is an arrow, now simple. If there is an arrow, what we have to do? No separate table, but we have to merge with entity set. Now, what we have to do? A1 table, B1 table, R1 table generally. But because we have an arrow, this R table, you have to merge with A table. These two will form one single table. So means this is going to be represented as two tables. What are the two tables? A and R one table, B separately one table. Now you tell me what happens in this case. A relationship B. Now cardinality I am giving one to many. Now how many tables you can expect and what are the tables?
Sir, A and RB.
Very good. Because one to many, arrow is from B. Because arrow is from B, now what you have to do? Actually, if you don't merge it, A, B, R, three tables. Because arrow is there from R, from B to R. So B and R together one table. So how many tables? Two tables. One is A and another is BR. Two tables, A and BR. So this way we have to merge it. So if you know this point, merging of R with entity set. So based on this point, almost 4 to 5 questions asked in the previous gate. In the previous gate, 4 to 5 questions. Okay. This is one of such question. Will you try this? It is a gate 2005 question. For 2 marks, it is a 2 marks question. Will you try?
Yes, sir.
Yeah, please. Just let me check how many are there in the meeting. Okay, Balaji, Lavanya, Ravi. Fine. Lavanya and Ravi, you are also feel free. You can ask any doubts. Okay, Ravi, Lavanya, happy. Ravi, you are asking something. UB is equal or less than? It is greater than or equal to, I think. X comma Y greater than or equal to X is mentioned, Ravi. You just check it out, what is asked in the previous one. Okay. Because I am not able to see this chart and screen sharing one at a time. Okay, fine. This is a question. You can speak out because only three people were there in the meeting. Lavanya, Ravi, and Rajesh, I think, correct? Balaji, Ravi, Lavanya. Okay, fine. Mhm. This is a question. You can speak out because I'm not able to see the chart simultaneously.
Option B.
Option B. Ravi, na?
Yes, sir.
Very good, Ravi. Option B. Perfect. Balaji and Lavanya. So, what is given here? Let E1 and E2 be two entity sets in ER diagram with simple single valued attributes. And it is mentioned R1 and R2 are two relationships between E1 and E2. Between E1 and E2, we have two relationships. One is R1, another is R2. And it is mentioned R1 is one to many. R1 is one to many. And R2 is many to many. Many to many means this one. As already we know that R1 and R2 do not have any attributes of their own. What is the minimum number of tables? So how do you calculate now? Actually, how do you calculate every entity one table, every relationship one table? Two entities, two relationships, four tables. But when a question is minimum number of tables, we have to check for mergings. Now, one to many means, Balaji, one to many means we have a key constraint from E2 to R1. Arrow is there from E2 to R1. Okay.
Yes, sir.
And many means no arrow. Now, arrow is there only from E2 to R1. So, now possibility that R1 you can merge with E2 and no mergings for E1 and R2. So, what are the tables possible? Three tables. One is E1 and another is E2 and R1 and another is R2. So, totally three tables: E1, E2, R1 and R2. So, totally three tables possible. Perfect. Okay. So similarly, you can try another question because it is important. Multiple times question asked. Okay, you can try this question. This is a question asked in GATE 2015. And any doubt with this question? Balaji is clear?
No,
Lavanya?
sir. Clear, sir.
Clear. Okay, fine. Lavanya, are you clear?
Yes, sir, I'm here, sir.
Yeah, very good, Lavanya. Go ahead. Just try for this question. It is a 2 marks question. Maximum 2 minutes you take. It is a numerical answer type question. You can speak out your answer. Don't worry.
Sir, 4.
4. Very good, Ravi. Yeah. What is given? Consider an entity relationship model in which entity sets E1, okay, and E2 are connected by many to many relationship here. That is R1, 2. These two are connected with many relationship. And E1 and E3 are connected by one to many relationship. E1 and E3. So between them, we have another relationship R13. It is mentioned one to many. It is clearly mentioned one on the side of E1, many on the side of E3. E1 has two single valued attributes. If all are single valued attributes, we don't have any problem. E2 has two single valued attributes. E3 has two single valued attributes. We don't have any problem with that single valued attributes. Now the question is, if a relational model is derived from the above ER model, then the minimum number of relations that would be generated. Actually, the 3 and F we need not to concentrate on it, because by default, the tables that we translate from ER model to relational model is 3 and F. Now, you look at what we have to do. How many entities we have? 3 entities. How many relationships? 2. Means total tables will be 5. But when it is asked about minimum, we have to go for merge. So how to merge it? Based on the cardinalities. Many means we don't have an arrow. One many means arrow is possible from the many side. Now many side is E3, it is arrow. Because arrow is there, this R13 you merge with E3. And R12 you don't have a merge, because it is a no arrows. So how many tables possible? E2, E1, E3, R13 and R2. So totally 4 tables possible. That 4 tables are E1, E2, E3, R13 and R12. Totally 4 tables. 1, 2, 3 and 4. Number of tables are 4. Okay. This way you have to solve. Simple. You can expect this time also the similar kind of question. You have to draw the model and check for the cardinality. Based on the cardinality, you put arrows. Based on the arrows, you can go for merges. That's simple. Okay. I think you are clear.
Yes, sir.
Done, Balaji. Now, so that's about the concepts of ER and relational models. So whatever I told, just give a focus on it, more focus on it. Those are the topics from where questions are asked. Next, when we go for the next chapter of functional dependencies and normalization, what kind of questions you can expect? So question you can expect, and previously it is asked, verifying the functional dependency. Functional dependency verification, a question. Second, questions on additional functional dependencies. If some functional dependency is given, we have to know which other dependency is possible. Additional functional dependency. Verifying the functional dependency, additional functional dependency. And equivalence also one of the questions. Equivalence of functional dependency. And I can say this is expected topic. So far no question asked, but questions you can expect this time. I'm giving a clue. This time in GATE 2025, you can expect a question on equivalence of functional dependency. And another is minimal cover. Suppose you are given some functional dependencies, you have to find what is a minimal cover for the set of functional dependencies. This is a fourth one. And the fifth one is finding the keys. Finding keys. Like question is about number of candidate keys question and number of super keys kind of questions. Number of candidate keys, super keys. That kind of questions you can expect. Multiple times questions are asked. And don't worry, I'll explain you one question for each topic so that every topic is going to be revised, right? And then you can expect a questions on properties of decomposition. We call decomposition property. Properties of decomposition. What are the decomposition properties? We have two properties. One is called lossless joint decomposition, and another is dependency preserving decomposition. Dependency preserving decomposition. And these are the topics from where the questions were asked purely on functional dependencies. And in that 6, this is expected topic, and the remaining 5 topics questions were already asked. Enough number of questions are asked. That's why I'm telling you this time you can expect a question on equivalences. And these are the topics from where you can expect a questions. Okay. Don't worry, I'm going to I'm going to revise these topics with respect to questions. Okay, my style of teaching is concepts through questions because it is a revision class. So I'll give a question, and by revising the concept, I will explain you the questions. Okay. Before me, I suggest you try. Now it is a question in GATE 2000. And I hope you know how to verify the dependency. If I'm talking about X to Y dependency, what is the meaning of X to Y dependency? Whenever X's are repeated, the corresponding Y's also be repeated. So means when the left hand side is same left hand side should have same right hand side. Then we can call dependency holds. Now here it is given some table and asked to find which of the following functional dependencies are satisfied by the instance. Now which dependencies are satisfied? So means you look when repetition in the left hand side, when left hand sides are same, if more than one tuple with same left hand side, if left hand side is same, expecting same right hand side, then we can call dependency satisfying. Otherwise dependency is violating. Tell me what is the answer for this question?
Sir, option B.
Bombay?
Yes, sir.
Very good. Ravi, na?
Yes, sir.
Very good. Yeah. XY to Z. When XY left hand side repeated, expecting right hand side also repeated. But left hand side XY 14, 15, 16, 32. No repetitions. So nothing to check in the right hand side. Z to Y means when duplicates in the left hand side, corresponding duplicates in the right hand side. Z here, the first and last tuples has same Z, because Z to Y means Z to Y. It means when left hand side is same, expecting right hand side also same, but right hand side is 4, 2, different na? So means this is violated. So option A is wrong. And similarly, you can check for YZ to X. YZ 42536322, all are different, nothing to verify, over. Y to Z, Y4562, all are different, nothing is repeated, this is also satisfied. So answer is option B. So the point is, when you have some dependency of the form X to Y, you just check is there any repetition, same left hand sides are there. If same left hand side, expecting same right hand side, then dependency satisfied, otherwise dependency not satisfied. Okay. And option C is wrong because X to Z. Here, look at option C. Why wrong? Option C, X to Z. Here, X same, left hand side is same, but right hand side expecting also same, but right hand side is different, na? 2, 3. That's why wrong. So C wrong, D wrong. So correct answer is option B. Okay, try one more question.
Sir, can we say X should refer Y uniquely.
X should refer Y uniquely. That is not always true. Why? Because X should refer Y uniquely means there should be no duplicates in the X side, but duplicates possible in the X side. So instead of saying X refers Y, we can say X determines Y, or Y depends on X. We can say like this. Okay. Suppose if you say X uniquely determining Y, it is a meaning that X should be a key, but X need not be a key. Okay. Are you getting?
Yes, sir.
So that's why you don't use the word referring uniquely. Referring uniquely is true only when the left side is key, right? And if you want, I can show you some example. YZ to X, nothing is repeated. XZ to Y, XZ to Y. Yeah, you look at XZ to Y. When you look for XZ to Y, just observe XZ 1 3, XZ 1 3. Now these two has same XZ, but it does not have unique Y. So this dependency is violated. So it means suppose you have some dependency. Let me give you an example: X, Y, Z, and Y determining Z. Say 1, 2, 4, 2, 2, 4, 1, 3, 5. Now, when I'm talking about Y determining Z, Y determining Z means whenever Y is same. Here, for these two tuples, Y is same. And then Z is also same. Now, dependency is correct. But is Y is a key? Is Y uniquely referring Z?
No, sir.
No. That's why I'm saying here. Unique reference is not correct. We can say determination is correct. But if it is uniquely determining, it is going to become key. Okay, that is a difference. I hope you understood, Ravi.
Yes, sir.
Hmm?
Yes.
So what we can
Yes, sir.
call, what we can call X determines Y or Y depends on X. But if you have X to Y, there is a chance that X is a key. There is a chance that X is a key. Means if X to Y is there, means there is a chances that X is possible to become a key. That is what I am telling you, chance. If X is key, then you can write X refers to X referring Y uniquely. But it is chance only, possibility, but not always. Okay, check. Now, next questions are possible on the closures. And because how to find a key based on the closures. So what is the meaning of X closure? All attributes that can be determined using X is called X closure. So this is a question on closures. Which of the following options is false? This is also one type of question. Try and let me know.
Sir, option B.
Option B. Very good, Ravi. Fine.
It's getting only B, G, A, sir.
Excellent. Excellent. Here, how to find the closure? Simple. X closure is equals to X first. Okay. And if LHS of some functional dependency, I'm calling it as previous closure. Okay, just I'm writing PC, previous closure. If LHS of some FD is in previous closure, then add RHS to previous closure and repeat. This is to be repeated. This is step. Simple. So what you have to check for option A CF closure, we have to check. What you can write, CF closure is CF we have to write. After writing, you have to check, is there any dependencies whose left side already in the previous closure? Now I am calling this a PC. Now look at this dependency C to G. Its left right side C already in the previous closure, so include right side. And F to E there, left side F already in the previous closure, so include right side. And G, left side already in the previous closure, include right side A. And repeat it. And A, like look at this, AF both in the previous closure, so you can include D, right side. Simple. And you repeat it, both DE there in the left side, you can include F. But are you getting B? No. So what you are getting, A, C, D, E, F, G. This is a correct. But question is about false. Now how to find BG closure? BG closure is B and G. Okay. Now, if you have left side in the previous closure, B already in the left, already in the previous closure, so include right side. What is the right side? C, D. And look, G in the previous closure. So G in the previous closure. So you can include right side A. Right? And anything else? C already there in the closure, G already added. So A, B, C, D, G. Oh, this is correct now. Ravi, you told option B or C?
Option B, sir.
But B is correct now. BG closure
Sir.
is B, G, C, D, A. Correct? Check where you have done a mistake. If anything, please ask me. What is AF closure? You write AF. Okay. AF closure is AF. Now both AF, LHS is already in the previous closure. Now include RHS, D. Now look at F already in the previous closure. Now include E. And DE already in the previous closure. DE. Include F, but F also there already. Any more to be added? Anything else is possible? No. No means AF closure is A, F, D, E. But you don't get C and G with AF closure. You're not getting. Question is about false. Answer is option C. Balaji, Ravi, Lavanya, are you okay with closure?
Yes, sir.
Sir.
So simple.
Yes, sir.
I gave you straightforward algorithm. Simple, like if any closure you want to find, include that attributes in the closure, we can call PC, previous closure. Now what you have to check, any dependencies. If left side of some dependencies in the previous closure, then add right side to PC and repeat it until no more attributes are added. That's it. It's very simple. And it is a question in GATE 2006, and this kind on this point also questions were asked. Okay, the question is on additional dependencies. These are different. This is the next topic. Suppose you are given a relation having some attributes A, B, C, D, E, and these are the dependencies. Now, question is which of the following functional dependencies not implied by the opposite? Not possible. The question is about not possible by the opposite. How do you find which dependency is not possible? Simple. Suppose if any dependency we have to verify. Suppose x2y we have to verify. Is it possible or not? I can say x2y is possible to be derived. It is possible if whenever you find the closure of x, that closure of x should contain y. Simple. Then that particular dependency is possible. Otherwise, we can say that particular dependency is not possible. Okay, are you getting my point? Whenever I have to check, is there any dependency x to y possible? We can say the dependency x to y is possible if the closure of x should contains y. If the closure of x is
Option D, sir.
good, then we can say the dependencies hold. Okay, I revise the topic. Now, tell me what is the answer for this? So how to check?
Option B.
Very good. How to check each option? Each option's left hand side closure you find to see right hand side. Now, when you look for option A, CD to AC, if you have to check, what you have to do? You have to find the closure of CD. Now, what is the closure of CD? C and D. Now repeat the process. CD to E, we have a dependency. Left hand side already in the previous closure, so include right hand side. Now, left hand side already in the previous closure, you can include right hand side. A. Left hand side already in the previous closure, include right hand side. Left hand side already included, already in the previous closure, include right hand side. With CD, what is expecting? Expecting A and C. Yes, possible now. But question is about not implied, but it is implied. So it is wrong. How to check BD to CD? Just check BD closure. BD. Right? And A not in the previous closure. This A, okay, sorry. This A not in the previous closure. CD. C is not in the previous closure. D there. So I should not include. If both are there in the previous closure, then only we can include. And B in the previous closure, include D. But D is already there. E not in the previous closure. Means BD closure contains only BD, but not C. So it is not implied. Question is about not implied. Answer is option B. You have to check in this way. I think it is clear to all of you. So using the same, you can try this question. It is a question asked in 2021 GATE, but question is multiple selection question. More than one option is correct. Try for this.
Sir, A,
The
C,
B
and
and
D?
C.
A, B, and
A, C, and D?
A, C, D, not B.
The B and C.
A, B, C. Very good. Very good. So how do you check this one? P closure. What is P closure? P, Q, R. Because P already in the previous closure, you can add QR. So with P, what is expecting R? Okay, this is correct. How to check PS to T? PS closure. PS. P already in the previous closure. We can add QR. Now both R and S of this dependency there in the previous closure include T. So what is expecting with PS? We are expecting T. Okay, this is also correct.
Sir, this is the RS closure, no?
Huh?
RS closure, no? RS tends to T, so closure we want to take RS or PS?
This is PS now.
No, sir, in above question, P tends to QR and R tends to T.
Okay, Akasha, you are talking about this one.
Yes, sir.
No, ma. Simple, simple. I think you are confusing. See, which one you have to check? Options we have to check, okay?
Okay, sir.
Which option we have to check? PS to T have to check. So to check PS to T, you take the closure of PS, not RS. Okay? You write. Sorry. You take the
Okay,
closure of
okay, sir.
PS to get T. What is PS closure? PS we write. Okay? After we write, check each of the dependency. If the left hand side of a dependency already in the previous closure, you include right hand side. So because P already in the previous closure, you include right hand side Q and R. Now check this second dependency. Now left hand side both R and S already in the previous closure. Now look, R and S both already in the previous closure. Then you can include right hand side. This is included. Now what is to verify with PS? We have to verify T. Are you getting T with PS? Yes. It means this dependency is correct. And what is the third one? PS to Q. And anyhow, PS closure we have to find. Already we have found. With PS, what we have to get? Q. Are you getting Q? Yes, it is also correct. And for option D, we have to look for R closure. What is R closure? R. Now we have to repeat the process. Left hand side of this first dependency P not in the previous closure. I can't use this to find R closure. And left hand side of this second dependency is R and S. R is there but not S. So I cannot use this dependency to get some more attributes. But in any more possibilities? No. It means with R you are not getting T. With R you are getting R only. That's why option D is wrong. So answer is A, B and C. Is it okay, Lavanya?
Yes, sir, I understand, sir. Thank you.
Okay, good ma, very good. Balaji,
Clear, sir.
clear, done, super. Ravi, I think you gave the answer. Okay, and the next concept, as I told you, expected. See my words. Okay, keep in your mind. As I told you, this is expected. 99% you can expect this question. This means questions on equality. Now look at, consider the following relation: vehicle service, vehicle color, capacity, wheels, owner, with functional dependency sets. Okay, set 1 has 2 functional dependency. Set 2 has 2 functional dependency. Means on the same table we have 2 sets of functional dependency. The question is, which of the following statements is true? Neither S1 covers S2 nor S2 covers S1. And first thing, please let me know, have you studied equivalence of functional dependencies? Have you studied equivalence of functional dependencies?
No, sir.
Sure, Lavanya and Ravi, you also?
No, sir.
No, sir.
Okay. No, I will explain you. Okay, don't worry.
Okay, sir.
Yeah, fine. See, actually, this is expected question. Guarantee, this time I'm telling you, guarantee you can get a question of this kind. Suppose on the same table, because vehicle service is one table, okay? On the same table, there are 2 sets of functional dependencies, S1 and S2. We have to check, is these 2 sets of dependencies are equal or not? How to verify equality? The equality is to be verified by checking, one minute, by checking is S1 covering S2 dependency. What is the meaning? S1 covering S2 dependency means dependencies of S2 may be directly or indirectly there in S1. What are the dependencies of S2? Vehicle to color, comma, capacity. Okay, just V tends to C, comma, P. Just for understanding, I'm just writing symbolic dependencies. Vehicle, color, capacity, wheels, owner. Okay. Now, what are the S2 dependencies? Vehicle to color, capacity. V to CP. Now, what is S1 covers S2? Dependency of S2 you can find maybe directly or indirectly in S1. To verify whether particular dependency is there in S1 or not, how do you verify? By finding the closure of left hand side. Just now we have discussed that this particular dependency is possible to be determined or not. How do you verify? By taking the closure, vehicle closure. Now this is, we are testing S2 dependency with respect to S1. So we have to take the closure of left hand side to see right hand side using which one dependency? Using S1 dependencies. In S1, what is vehicle closure? Vehicle closure is vehicle first. Okay, vehicle closure is vehicle first. How do you find the closures if the left hand side of dependency already in the previous closure? Vehicle is already there, but color is not there. Presence of both left hand side should be required, but vehicle is okay, but color is not there. So I can't use FD1, but wheels is not in the previous closure, so I can't use anything. So means vehicle closure is vehicle only in S1. It means S2 dependency, vehicle to color, comma, capacity is not determined by S1. V2CP, this is not determined or not covered, we can say not covered by S1. V2CP is not covered by S1. It is not covered by S1. So what is, we clear S1 covers S2 is wrong. Simple. Here S1 covers S2 is wrong. Both is also wrong. Fine. Now what we have to do? We have to check is S2 covers S1. Okay. I'm writing S2 covers S1. What is the meaning? We have to check S1 dependency possible to be determined using S2. Now what are the S1 dependency? Vehicle color determining the capacity. VC determining P. How to check? How to check? We have to check closure of VC means LHS closure to determine RHS. This VC to P we have to check with which dependencies? S2 dependency. Now first thing, VC closure is VC, vehicle capacity, vehicle color. Okay. Now look at in S2, vehicle already in the previous closure, so that we can include right hand side. Right hand side is color already there, capacity P added. Okay. So what is expecting? VC should determine P in S2. Yes, in S2, VC is determining P there indirectly, we can say. S2 is covering VC to P. Now, can you tell me wheels determining vehicle, wheels determining vehicle, comma, owner. Vehicle determining, sorry, wheels determining vehicle, comma, owner. How do you check this? You have to find the closure of vehicle. So means S2 dependency you have to check. Sorry, what I have done? Sorry. S1, S2 covers S1 means S1 dependencies we have to verify. Sorry. S1, S2 covers S1. First
Possible, sir.
dependency, S1 we have verified. What is second dependency? Wheels determining vehicle capacity owner. So means W determines that VPO. We have to check. How do you check? By taking the closure of W. Wheels closure we have to take. In which one? S2 we have to check. So in S2 we have to check wheels closure. Is it possible or not? You verify. Possible?
Possible, sir.
Ravi, possible. What about this? Wheels closure is
Possible,
wheels.
sir.
Very good, Lavanya. Balaji is okay?
Yes, sir. Possible, sir.
Excellent, excellent. So wheels closure is wheels. Fine. Now, because we have to use S2 now, wheels already in the previous closure, so that we have to use right hand side, that is vehicle and owner. And the vehicle first dependency, vehicle already in the previous closure, so that we can have color comma capacity. So what is expecting with wheels? We have expecting vehicle, capacity and owner. This is also possible. So means this S2 is covering S1 is correct. So what we can call S2 covers S1 is correct, but S1 does not covers S2 is also correct. So answer is option B. Option A is wrong. This is expected type. I'm expecting 99% chances are there. This kind of questions you can expect. So you have to check S1 with S2, S2 with S1. If both are same, like assuming if S2 is covering S1, okay, S2 is covered, S1 already correct. If assume if S1 also covers S2, it means with S1 you are getting S2, with S2 you are getting S1. If both are correct, then we can call S1 and S2 are equal sets of dependencies. Those are called equal set of functional dependencies. Okay, I'll give you one simple question just for because you haven't studied this before. So I'll give you a simple question. Suppose there is some dependency sets S1, AB determining C, D determining AC, and also one more I'll give you. A determining B. I'm giving S2, A, B, not, small correction. A determining BC. Now tell me, I'm giving options. Only S1 covers S2. Only S2 covers S1. Both S1 covers S2 and S2 covers S1. D, none of the above. So means neither S1 covers S2 nor S2 covers S1. Okay, will you try?
Only S2 covers S1.
S1 not covering?
Sir, S1 covers S2, sir.
S1 covers S2, correct. Not S2 covers S1?
Still doing, sir.
Okay, okay, do it. Very good, very good. Keep it up.
Sir, both will cover, sir.
Very good, very good. Ravi, right?
Balaji, sir.
Balaji, very good, Balaji. So option C, correct?
Sir,
Yes, sir.
Excellent.
because there is a dependency A to B in S1.
Very good. Very good. So what is the answer? Option C. Okay. Is it okay? Hello.
Yes, sir, it's okay.
So S1
Okay,
covers,
sir.
yeah, S1 covers S2 means dependencies of S2, they're in S1. Now, A2, BC, S2 dependencies. How do you check? A closure. What is A closure in S1? You have to check. S2 dependency you check with S1. A closure is A. With A we have B. With AB we have C. What is to verify? A to BC. Yes, that is possible. D to A, by looking we can say D to A directly there na. So S1 is covering S2. This is correct. So what is S2 covers S1? So means check S1 dependencies with respect to S2. What are the S1 dependencies? A, B to C. How to verify? AB closure. What is AB closure in S2? AB closure in S2. A, B, and with A we have both BC, right? B already there. Now add C. So that with AB you are going to get C, correct? This is possible. And D to AC, you look at D with D closure. When you take the D closure with DA with AC possible. This is also correct. And A to B, here you look at directly A to B there here. So means S2 is also covering S1. It means both S1 is covering S2 and S2 is covering S1. If both are covering each other, we can say the dependency sets S1 and S2 are equal. So this is an expected type of question. This way you can expect a question. And moreover, you have to give focus, concentration on expected type. Why? Because regular type of question everyone will do. You will do, others also will do. This kind of expected questions, most of the people, they are not going to do it. There it finds a difference. You are going to get extra marks, others are not getting. That's make a sense. You are ahead with when compared with many of the others. So this is 99% I'm expecting this time. You can expect a question on this kind of questions, equivalences. And next we'll see the minimal cover sets of dependencies. I hope you have studied minimal cover because questions were asked on minimal cover. And we'll see how to find questions on candidate keys, super keys, and different type of questions and properties of dependencies. Then we'll discuss questions related to normal forms. Then I'll go ahead with relational algebra questions. Relational algebra is very, very important. These are all the things I'm going to explain you. And then we'll go ahead with SQL. What extent possible for today, we are going to finish it. And SQL, different concepts, different questions. And then transactions and concurrency. And then I'll go ahead with recovery management, how questions are asking on recovery management. Then finally going with indexing. So indexing kind of questions we'll discuss, right? So this is a plan for this revision, so that I'm going to cover every concept from where questions were asked the previous gate. And also I'll parallelly give you some expected questions instead of making you to solve all previous gate questions only, because all gate aspirants are going to solve the previous gate questions. I'm going to make you solve some other questions which were not already you might have solved. Some different kind of questions also I will make you solve. Okay. Actually now I will log in again at 7 p.m. You also please be logging on time so that we should not waste any time. Okay. Thank you.
Okay, sir.